Yep.
Hello, welcome to Cpp.chat, a sometimes weekly look at what's going on in the world of C++, chatting with guests from the community. And we'll get to this week's guest in a moment. But first, in accordance with our contract, we need to establish our preconditions. John?
All right, so I'm going to read the disclaimer. Dear customers, your order is valuable to us. We would like to understand and appreciate how much we care for your orders. For orders received after the cutoff time, we will try our best to deliver those by February 14th February. However, no such commitment is given. It may be delivered by 15th February. For those of you who are at all interested in disclaimers, Google Valentine disclaimers and have yourself a lot of fun, because there's some amazing disclaimers out there. And I really couldn't find a great one to capture it. You just have to enjoy that on your own.
Unfortunately, if you're listening to this as a podcast, you're probably too late for that. But
yes, it may be delivered by 15th February.
Yes,
we are recording on the 14th. We should say that.
Yes. So talking of contracts, that's a nice segue into our guest today, because we have Björn Fahller, who is coming on because of an email exchange earlier this week. Now, Björn was a speaker at C++ on C last week, and he spoke about contracts there. And he felt that because contracts is going to be one of the topics being discussed at Kona next week, and there's a little bit of a controversy brewing over it. It'd be nice if his video got out before Kona, so more people could actually get to see it. So I asked him if he wanted to come on the show to talk about it as well, and for some reason he agreed. So here he is. So hello, Björn.
Hello there, Phil. Hello, John.
Hello.
Yeah, what I said was that, yeah, there is, as Phil mentioned, there is some controversy about contracts as they are currently specified in the language specification. And in my talk, I made some points, some good and some bad, and I'm pretty sure that there are an argument in that debate, although I'm really not sure which side.
So before we get into that, though, we should talk about C++ on C. I'm anxious to hear about this. I talked briefly with Kate, and she seemed very excited. What's your take on this, Phil?
Yeah, it was fine.
No, only slightly partial.
No, I think the summary is it went really well. Not perfectly, but really well. In fact, a lot of people came up to me afterwards, or even during, and said how great it was, how much they appreciated this and that. It was amusing.
I know how gratifying that is.
It was amusing. One of the common themes was so many people said it's so great for the first time. So, so I have actually requested feedback. I sent out a form to everyone, and I've been getting that coming through. And I've allowed people to remain anonymous, although they can choose to put their name against it. So I'm hoping that we're going to get some honest feedback through there. And I've got one or two things through that have been some fairly transparent feedback already, which is all good. Most of it is stuff that I did know about. We had a couple of problems with the temperature for a start. It was very cold. It's not surprising for the time of year in the UK, especially by the sea. What we didn't realize was how much that was going to leak into the venue. So that was a problem at times. And we had some problems with just the sheer numbers for lunch, especially on the first day. All things that we can probably address next time. So it's all valuable feedback. But nothing particularly major beyond that. So other than that, it was really a good success. The videos should be coming online very soon. And Björn's one will be in the first batch. I prioritized it for that reason. And in fact, hopefully that video should be published just after this show. So people listening live will be able to actually go and see that to see what we're talking about. In fact, I've set up a forwarding alias, cpp.chat/videos will redirect you to the YouTube channel, which is currently empty. But by the time you hear this, probably that will be populated by all the videos. So yeah, I think that's my summary now.
Amazing turnaround on that. That's really impressive.
Well, we've got the same video guys who do the ACCU conference. Quite impressed with their work. Glad that they agreed to come and help. So they're quite old hands at this.
So Björn, do you have any comments from a speaker's point of view there?
Yeah, it was embarrassingly good. It was an extremely friendly atmosphere. I've been to a few conferences by now, and it was very welcoming, extremely welcoming. I appreciated it a lot.
Well, and congratulations to you, because I know that the number of submissions was really high. So to have been accepted is something to be proud of.
Indeed, absolutely.
And having watched the video, I'm the first person to watch Björn's video. I'm definitely glad that we got him in the schedule. It was a great talk. Thanks, Björn.
Great.
Thank you.
All right. I guess there's some other conferences coming up we should mention. Registration is open for ACCU and also for EMBO++ embedded. And I think you may have some thoughts on that one as well. Bjorn, have you attended that conference before? I know that you do embedded stuff.
Actually, I currently don't do embedded stuff, but I have been doing that for a number of years. But no, I've never been to EMBO++, unfortunately. Maybe one of these days.
All right. I was just last night talking to, or I guess Tuesday night, I was speaking to one of the organizers there. Kind of sounds like a lot of fun. C++ now, we're working on, the review committee is very busy right now. Most of the reviews are done, and now we're trying to figure out what the actual lineup is going to be. So we're right in the middle of it for C++ now. Core C++, registration's open. Do you know, are they still accepting submissions on speakers? I don't think they are anymore.
I think that closed, if I remember correctly.
Okay, all right. The Italian C++ is scheduled for June, so that's a little ways off. And I think they have, Andre is keynoting on that one, right?
That's right. Yep.
Got to really score big on that one. All right. There's a Catch 2 release. Do you want to tell us about that?
Yeah, I put this in here because I think we missed the last couple of releases, and it's a bit of a shame, really, because I'm the original author of Catch and Catch 2. But I have to say I've been quite hands-off for a while. So I've missed the last few releases. So I think it was yesterday or the day before yesterday, 2.6.1 was released, which is mostly just bug fixes. But in the previous few releases, generators have now been promoted to being production ready. This is the ability to data parameterize the text. So I put in a beta version just last summer, and that's now been progressed to the point they consider it production ready. So that's quite a big thing. Also, a template type parameterized tests is also in, and some stringifications for stood optional and stood variant. So although Catch itself relies only on C++11, there are conditional support for various C++17 features as well. So I thought that was worth mentioning.
For vocabulary types.
Yeah, that's right. Yeah.
Excellent.
Yeah, so that's Catch.
Well, thanks for that release. We also have a note here about, I did a guest blog post for Jonathan Bacara has a blog called Fluent C++, which is an interesting blog to read and generate some good discussion, because he's really kind of pushing what he's recommending, that real best practices and a bit of a challenge. And so he had recently, a few weeks ago, discussed for each and range-based for loop, and I couldn't help but chime in. I sent him kind of an email about this. He says, well, you should turn this into a blog post. I said, okay. But basically, it was it's my thoughts that it's kind of weird that we have a way of implementing algorithms and we pass lambdas into the algorithms, but there's this one special algorithm called for each, which is built into the language and does something different. So you can call the library version of for each, or you can do a range-based for each. But if you use the range-based for each, which is just a range-based for, the syntax is different because you're not passing in a lambda. Instead, you have this silly loop. So that's my take on it. You can look at it. It's generated some interesting discussion, both on his blog and also on Reddit.
I have to say I haven't read the blog yet, but I'm quite interested in it. I have opinions already, but I'm not going to share them until I've read it.
I think that one of my arguments was that particularly when we get ranges, we're going to have more and more tools that leverage lambdas even better. But one of the responses is, yeah, but those same ranges features can be applied to the range-based for loop. So it kind of makes that more usable. It's really, I feel like, pretty limited right now, but with ranges, you'll be able to do more interesting things with range-based for loop. So that's something.
Yeah.
Makes sense.
You also have another thing. If you're using, if you already have function objects and combine them using higher order functions, etc., then I think the for each algorithm is a better fit because you don't have to name the loop variable, which is actually not used for anything other than to pass into a function object.
Yeah. No, I think it fits better with the way we do everything else, and that was kind of my argument. If you want to be consistent, you'd use for each to handle that particular algorithm, just like you have a function to handle all our other algorithms. You can imagine someone actually deciding, well, we're going to take all the algorithms and build them in as language features. That would just be insane. Nobody would think that's a good idea. But we've got this one particular one that's built in as a language feature, and we all think that's a great idea. And I'm a little skeptical about it. That's all. It's not like I feel strongly about it like I do with East Const.
Do we need to get range-based for loop wristbands?
That's right. That's right. So there's one other announcement I want to make, and that is that we're looking for someone to present papers at committee meetings. Our idea is if there was an individual who would like to be going to committee meetings but needs to have some help with expenses, then that's what we're looking for. Someone who will study and can represent specific papers in exchange for financial help to go. And what we're really looking for, someone who can commit to go to almost all the meetings. That's what we want, is a consistent voice representing specific papers. So if you are interested in going to the committee, are articulate, can understand language issues and library issues, and can talk about those to the committee, and are willing to represent a paper and would like to go to the committee meeting and need some financial help to do that, please let me know.
I think this is a really important initiative. One of the criticisms of the standardization process is it's seen as something that's only possible for those that can either afford to send themselves or have a company that will sponsor them. And with the meetings going on in all sorts of places around the world, I mean, next week it's in Hawaii, there's a lot of people that would be able to say something valuable that just can't afford to go or don't have the opportunity. And this doesn't completely solve that problem, but it's a really good step in the right direction. So I think this should be publicized far and wide.
Yes, if you're interested, please contact me in any of the many ways that you can contact me.
There'll be links in the show notes.
Yes. All right, are those all our announcements? Are we ready to talk about contracts?
I think so. I think we've established our preconditions now.
All right. Well,
All right.
As a background, what was your talk about, and what did you cover in your presentation at C++on-C?
Okay. To begin with, I have to go a little bit further back in time. I have enjoyed using contracts. I see contracts more as an API design principle than a language feature. So I've been using it for, I don't know, 25 maybe years, something such. But even though you don't need it to express your APIs in a contracted form, it's a good thing to get language support, because with language support you get tools, hopefully, and you get an ability for third-party libraries to ship with contracts. Currently, it's kind of a mess. Everybody has their own way of expressing contracts. So when I heard that contracts were coming to C++, most probably, that they were proposed and then they were voted in, I was really excited about that and decided to dig in and learn about the language support as it looks, and decided to present my findings. So also then, based on my experience with software developers over the years, I assumed that most developers are not particularly familiar with the ideas of design by contract. So I devoted roughly 1/3 of my talk to just introduce the ideas. What do we mean? What do we want? And so introduce the notion of a precondition, of a post condition, and also a class invariant, what they are, how you think about them, etc. And then over to
some of our audience. I mean, I'm always astounded when I ask in one of my classes how many people know programming by contract as a technique, and a lot of them haven't heard about it. I'm really surprised because it's so valuable. Can you share just those, talk about preconditions, post conditions, invariants real quickly for those people in our audience who aren't?
Yeah, sure. So the idea is really when you have a function, any kind of function, anything that is callable, you can set up a precondition where you're stating the obligation on the side of the caller. What must they fulfill for the call to be legal? So you define the terms for when the call is allowed, and this precondition can be about parameter values. It can be about an object state, combinations thereof. And then on the other hand, you have post conditions, which are an obligation on the implementation, which says that if you call me within the limits of the contract, then I promise to deliver that to you. So you have a constraint on what the function is allowed to do and what the caller can expect. And one really good thing about this, apart from making the API quite clear, is that it can be a very, very quick argument settler when you have found a bug. Because if a call has been made violating a precondition, then either the caller has a terrible bug, or the caller has obviously violated the contract, but either the caller has a bug that caused it to do that, or your contract is really bad. For example, I joked in my presentation that you can state as a precondition that the next call to random must be 4, and that is legal, but a very bad idea. And then we have the idea of a class invariant, which is a more difficult thing to explain. It's some condition that must hold true always for a valid object. And in my experience, it's very helpful if you can come up with a good class invariant, but it can be very difficult to do so, I think, anyway. And especially in C++, since we allow moved from objects to exist in an indeterminate but valid state. So how do you capture that in a contract, in an invariant? But that is a very quick idea about what we mean with contracts, with preconditions, with post conditions, and invariants. So was that good enough intro?
I think it's good. Now talk to us about what's the proposal to put that idea, because that idea by itself needs no language support at all. As you said, you've been doing this for many years. You can implement, in fact, if you look at the standard also often talks in standard functions using the terms preconditions and postconditions, right? So you don't need language support in order to do this. But we do have a proposal, and in fact, it's in the draft, correct? That's our state, right? It's not in, it's in the draft.
It's in the draft, correct.
Yeah. So tell us what that proposal is.
So that proposal says that on functions you can define preconditions and postconditions, declare, I guess, rather. Declare preconditions and postconditions, and they are written as attributes on the function. So you can say that this function expects and some condition, which then is a precondition, and you can list several of them, and also that it ensures things which are then post conditions, and there are no invariants in the proposed standard. And also one thing that is missing, when I first learned about the design by contract, that was in university back in the Neolithic age, and we used the Eiffel programming language, which had all of these, and it had also a way of referring to old values. So you can say in the Eiffel programming language, you can say a post condition is say the value returned is some value calculated from the previous old value returned from a function, and this ability to refer to previous state does not exist in the draft standard either. So that is missing. But you can have declarations with attributes on functions defined where you say preconditions and postconditions. There's also an assert, which is kind of interesting that it is lumped together, because it really is. You can use it as a drop-in replacement for the assert macro. So anywhere where you can have a statement, you can have a assert attribute. The difference between these and the assert macro is that the assert macro is either on or off. And when it's on and triggered, then you call abort. And there are no ifs and buts, so that is what it does. Whereas the proposed feature is a little bit more fine-grained. You can say for each precondition, postcondition, and assert, you can specify a level, saying that it's on a default level, it's on an audit level, which is sort of intended for more expensive checks that you maybe don't always want. And also in the other way, in the other end, you have checks that are marked. You can mark them as axiom, which are then never checked, but they can be. Yeah, sorry.
So, for example, if I was writing a binary search routine, I could say that my precondition is my data is all sorted. Now, I wouldn't want that checked regularly because that's an order n verification. That's going to kind of defeat the purpose of having a binary search as my algorithm, right? Yep. So I want to tag that, and I say this precondition is an audit precondition, meaning only in the most extreme circumstances, when you're really, really debugging your code full on, troubleshooting problems, then you would do the check. Otherwise, in the default mode, don't do this check because it's too inexpensive a check. So when I write the check, whether it's a precondition or a postcondition, when I write the check, I specify at that point essentially what its cost is by saying if it's audit or default.
Yes, that is correct. Or at least that's my understanding on it. Yeah. But then also you have axiom. Axiom are never checked, or rather, no code is ever generated to do the check. But the code optimizer can take advantage of it. Static analysis tools can take advantage of it. Your IDE could take advantage of it and flag problems for you. So there's that. And then when you compile, you can say that now I'm compiling with the default level, or now I'm compiling including also the audit checks for, like you mentioned, the heavy debugging sessions where you really, really want to know exactly what happens. And also you can compile with all checks off if you're a bit wild and crazy.
All right. So I think I derailed you from talking about what was your particular presentation So you said that you gave a little bit of background on what contracts was,
Yep.
and then what did you talk about in terms of this specific proposal?
Well, pretty much what I just said. So
Uh-huh.
I realized I could have done the presentation in 10 minutes. Now, I went back to my introductory example and applied these attributes and discussed the things that we cannot express, because in my example I actually did refer to previous data and such things, which the language proposal doesn't allow for. But then after that I went on to very much quote the standard or proposed standard in various ways, and how you can, what you can do, what you cannot do, what are the difficulties. So one of the interesting things, for example, is that you can have your own violation handler. The violation handler then is called when a contract is checked and the condition evaluates to false. So then you call a contract handler. And there are some interesting things there. One of the things that surprised me when I read the draft is that it very explicitly says that there must be no programmatic way to set the violation handler or to query what it is. So that is something that you must use some other technique to get to. And there is a proof of concept fork of Clang available. And with that one, you can set it as a compilation flag. You say that this is my violation handler and give the name of a function. And then I went on to talk about some of the interesting problems with that. For example, when contracts are checked in a function, both preconditions and postconditions, they are checked. The checks are compiled into the body of the function. That is an important bit to understand. I think I would prefer actually if at least preconditions were checked out before entering the function, but they are checked inside the function. And there comes an important thing, because it is allowed for the violation handler to throw an exception, which sounds reasonable until you realize that it can be called from inside a no except function, and then you're in trouble.
So the function's no except, but potentially the handler is not.
Yeah. Yes.
Yeah, I see.
One reason that's particularly important is because a lot of the time we are looking to put contracts in instead of using exceptions, particularly logic error exceptions.
Yes.
And so by removing exceptions, we then want to make the function no except. It's just a natural progression from that. So this is the real sticking point in that progression, I think.
Yeah.
Well, I'm just going to parenthetically say that logic error exceptions are an abomination and are themselves a logic error. Okay, let's try.
Yes, that is
for this reason.
Correct. There's also, let me see, where were I? I think I lost something. Anyway, there's also a way to say that in this proof of concept Clang fork, you also have a flag where you can set a continuation mode, where you can say is execution allowed to continue after a contract violation or not. By default, it's not allowed to continue. It calls terminate after the continuation handler, and that is, I think, an interesting thing, because at least in my view on how you use contract is that by definition a violation of a contract is a bug that you will have a difficult time recovering from, because if you could recover from it, why on earth was it a contract? So I'm not entirely sure I understand why you would want that, but I'm sure people will find really good reasons.
I think testing is one of the reasons. You want to test something by forcing a contract violation and just make sure that it actually handles it correctly.
Yeah, but that is sure. But then your object under test continues execution in violation of its contract. So how?
Yeah, I'm not saying there's an easy solution to that.
Yeah, there is a cop-out that is explicitly mentioned in the proposal, and that is you can cheat and leave with via long jump if you're crazy enough.
That's a C++ friendly way of doing it.
Yeah.
But it might be good enough for testing.
It actually, when writing the talk, I actually did some such experiments just to try it out, and yeah, you can do that, but no, I wouldn't. Not for any other purpose than just to learn.
So what is the controversy that Phil alluded to for what's in the standard now? Is the controversy about what's been voted in, or is it about a change that's being proposed to what's already been voted in?
To be honest, I'm not entirely sure. I think some of the controversies are regarding to what extent the optimizer is allowed to make use of contracts when they are not checked. So, in fact, there is one paper that is in the mailing for the Kona meeting, P1290, written by Daniel Garcia and Ville Voutilainen, about avoiding undefined behavior when you have some contracts that are checked and some contracts that are not checked. So sort of set the rules for when the optimizer is allowed to make use of.
So in other words,
yeah.
if I have a precondition that says the data is sorted, for the example that I gave earlier, if it's not checked because we're not in audit mode, we're just in the default mode, so it's not actually going to check that. Can the compiler actually assume that if it had been checked, it would have been true? Because otherwise we're outside the contract and it's essentially undefined behavior. So the compiler can just assume, no, it really is sorted, and make that assumption and build code based on that being true.
My understanding of this paper is that it's meant to say that the compiler is only allowed to take advantage of information that it has from contracts that have already been checked. And I'm not sure I agree that that is a very good idea. One of the examples that is used in this paper is a function that takes a pointer, and it has a precondition that the pointer must not be null under any circumstances. But then inside the function body, they still have an if null check and does different things. And then they're arguing for would it be a good idea to allow this if null check, because if the precondition is not checked. And in my opinion, it's that is sort of a crazy way to write a function. If you have stated,
well, but you can wait a minute though. Imagine that I'm calling some inline function.
Yep.
So I didn't write the function that's being called, and that function does a check to see if a value is null. And I'm assuming, and I'm passing it knowing it will never be null, but I'm just calling the function. I mean, it seems to me quite plausible. I understand. I think where you were going. You were saying it'd be crazy for me to say this function, the pointer has to never be null. Why would I ever check it in my code? But I might check it in my code because I might call some other function.
Indirectly, yes, you're absolutely correct about that.
And the compiler could see that because it's an inline function and can say.
Yeah. But what my take on this is, at least I think it is, unless someone can point me to something that I have missed, is that if you have stated as a precondition that this pointer must absolutely not under any circumstances be null, then yeah, of course the compiler is allowed to elide those checks in a further down inline function that is being called, I think. Because you're already prepared to terminate the program in the event that it was null.
Right. And I agree with you. If we take preconditions seriously, then that's what we need to do. I think what happens is that people looking at this saying, well, yeah, it's a precondition, but maybe they didn't mean it. And that just, then why are we doing this? No, it's a precondition. We've stated this. If this isn't true, all bets are off. We have no idea what the code is going to do.
Yeah.
And so we shouldn't do things like say, well, you have to pass in a non-null value, but just in case you did, I'm going to check and throw an exception. Yeah. That's what we're trying to get away from. That's exactly what we're trying to get away from. We're specifying this is the precondition, and now we're going to write code based on the assumption the precondition's met, because that's why we said it was a precondition.
Yeah,
we're essentially giving ourselves permission to make that assumption in writing the code.
Yes. So if you're writing in a very defensive way, that you're prepared that maybe it could be null, then remove the contract. Remove the precondition.
Make it a wide contract saying I'll take any. There's two ways to write a square root function. One is to say you can't pass me a negative number and all bets are off if you do. And the other is to say if you pass me a negative number, I throw an exception. Yeah. Both of those are perfectly valid. And you decide what your contract is going to be. Yeah. But if you decide, don't mix them. Yeah, don't mix them. Don't say, oh, you must pass me a positive number or zero, but just in case, I'm going to check for it. That's just no, that's the wrong solution.
Yeah, I think so too. But then there are also there are two other papers that I think are really interesting. Another one also from Ville Voutilainen that I don't quite understand, P1320, where it says you can specify contracts on the implementation rather than on the interface, which I find kind of weird, because I'm guessing that they are thinking about internal contracts on private member functions or something such. Then you don't want to clutter the interface with those contracts. But I wonder if you find yourself in that situation, if you haven't actually discovered that you have sort of another small class in there that wants to break free and have its public members have contracts visible, and then it's a private detail in this class that it uses this other class, I believe.
Yeah.
But another one is really interesting, written by Joshua Byrne and John Lurkos, P1429, with a clickbaity title, Contracts That Work. They have the observation that in terms of catching bugs, different contracts have different value. So they say that they want to be able to differentiate between contracts that where violations are survivable and when they are not, and also to compile with different checking levels depending on contracts. So they note specifically that preconditions catch way more bugs than postconditions do. So maybe be able to compile preconditions with stricter checking than postconditions, for example. I haven't made up my mind about that, if it's good or bad, but I find it's an interesting take, I think.
Yeah, I'm not sure. Maybe that's the kind of thing that could be done at a tool level. It doesn't have to be in the language. Maybe you could tell the compiler, this is what I want. I want you to compile in the preconditions, but not the postconditions. I don't know. I mean, I guess it's a valid point.
Yeah, I agree absolutely about the observations. There is no disagreement there at all. I'm curious about what the effects would be if we had this in the language. I don't know.
Well, one of the things that I think will be very good, although Robert in the chat room has made something somewhat cynical. He's saying that he thinks that with contracts in the language, programming by contract will be just as popular as it is now. Which is, I think, is a way of saying it's not going to impact. But I think that's not true. If it's in the language, I think people will know about it. I think the vast majority of C++ programmers, as I said, that I asked this question in my training, do not know about programming by contract as a thing. And I think they will if it's in the language. They're going to learn it because it's like, well, what is this feature? And they say, okay, well, let's set you down. We're going to talk about preconditions, postconditions. We're going to talk about invariants. And we're going to talk about what these things mean. And maybe we even talk about wide contracts and narrow contracts. Yes. Because these are concepts that it's interesting. It was something that Dave Abrahams kind of pointed out to me. He says, even if you don't use this terminology, even if you've never thought about programming by contract, in effect, if you've written code at all, you've had to deal with it. I mean, you had to think in terms of, well, when is it safe to call this code? And you probably documented this function, call this only when the container is not empty or something like that. You had to have, and you didn't use the terminology and you didn't think about it rigorously, but if you wrote code at all, that had to be the case. Yeah. And I think it will straighten out a lot of things. I mean, I've seen code where it's very clear that the caller is passing data that the callee is not expecting, but it's not clear who's wrong there, right? Is the bug on the code being written because it wasn't doing proper error checking, or was the code on the caller? If we don't specify what the contract is, it's impossible to know whose fault it is.
Yes, that is exactly as I mentioned earlier. Now, I've been in a number of debugging sessions where after hours of hard work, we actually found out exactly what the problem is. And it is just what you said. A function was called with an unexpected value. And then the argument starts. Who's to blame? Was it a faulty implementation that obviously should have taken care of this situation? Or was the caller at fault for calling it with the wrong parameters or in the wrong state or whatever? And had the contract been there, the discussion would have ended right there.
Well, had the contract been there, the bug probably wouldn't have happened. Because had the contract been there, either the function would have been written to handle it, or else the caller wouldn't have called it that way.
Hopefully, but I mean, mistakes do happen. But if they do, then it's to begin with, the debugging session is much shorter because you know that the program terminated because this condition was violated. So then we know exactly what happened and when and where, and the blame is very easy to find. There is one possible situation, though, that we can argue if the contract is correct, or maybe it should have been written in a different way. But it's still a much more productive discussion than to argue about whose fault is it.
There's one point that I do agree with Robert Ramey on in the chat. He says we'll have to agree to disagree. So, in fact, there's been quite a lot going on in the chat. It's been very active today. Yeah. Won't have time to cover all of it. But one point that has come out, ironically, has been particularly pushed by Robert, and I do agree with this one, which is that we should really be leaning on the type system a lot more to remove a lot of these cases where we might be using contracts. And I agree with that, but, and here's the but. So the way I see it, if you establish a type that says, once you have this type, you can make all these assumptions about it because it's encoded in the type. There's still got to be a point where you get information into that type. These boundary points, you're going to need to do some validation, and the type of validation is going to depend on the specific use case. So you might want to do some sort of runtime validation because you're getting your inputs from I/O, for example, reading in from a file or across the internet. And then you'll need to do a runtime check and take a runtime course of action to maybe do something else instead or report the error. But if it's information that's coming from within the code, just from somewhere else in the code, and you want to make the assumption you're getting the correct information, then it's a bug if you don't. And that's really the domain of contracts. So even if you're using the type system to full effect, you still need something like contracts at these boundary points in the code. You just need to push the boundary back as far as you can. That's my take on that.
Yeah, I agree that we can rely better on types, but I think all you're doing is moving You're moving the contract, and it's probably a good thing that you move the contract. Let's do that. I'm all for that. But you haven't obviated the need for contract.
Yes. Yeah, move everything you can to compile time. Absolutely. But I think some things are not reasonable to express at compile times. You probably don't want an empty queue to be a different type from a queue that has elements in it, I think.
That's awkward in C++. There are languages where that's
there are languages where that absolutely works, but C++ is well, it's doable, but it's really not convenient.
Yeah, I mean, an example that I've seen before that is sort of close to that is a source and code where there was a lot of strings being passed around, and at various levels being checked to see whether they were lowercase or making them lowercase, mostly so they could be used as a lookup. And what I noticed was these strings were just being checked again and again and again. Yeah. So I just created a lowercase string type. So it validates its input once, and then you pass the lowercase string type round it, where it doesn't need to be checked again. It's all enforced at compile time. So that was just a very simple example, but it's using just a slightly different type that encodes the semantics of what you wanted. Yeah. Like I say, it'd be awkward to do that for everything, but you pick your battles. There are some things that you can get some benefit from doing that. I'm a big proponent of correct by construction where you can. We're moving to a world where we can do more and more with that as well. So
yes, yeah. There is also another thing that usually comes up. It hasn't come up in this discussion because you're boring and agree with me. But one thing that I'm often met with when I bring this up is this idea that it's dangerous to use these constructions because you terminate the program if you have a problem, and that is never acceptable. The program must always continue executing, which I kind of disagree with, because even though a user of your program will be really pissed off if you crash, they will probably be even more pissed off if you corrupt their data. I actually have an interesting story about that if you want a war story.
That's what the show's about.
That's what the show is about. It was ages ago. I worked in we had a real-time system, and it was flaky as heck. It was crashing all the time, and there was this dogma that we must always be able to handle all situations. It must never be allowed to crash, and it crashed a lot. And it was even to the extent that they didn't want to. The MMU was set up such that access via the null pointer was just another access. The only problem with that was that you just couldn't. You wouldn't be left alone with your data at null because so many used it. And after a while, a colleague and I got totally fed up with this appalling situation where the system was crashing left and right, and we could never understand what the problem was, except that we saw that, yeah, the data structures are corrupt, but we don't know when they became corrupt. So we sprinkled the system with asserts everywhere. Everywhere we could see, everywhere we found a problem, we just sprinkled with asserts. And sure, the next couple of weeks weren't pretty. It crashed extremely much. But then it crashed with information that we could use to understand what the problem was, so we could fix them. And it wasn't more than 2 or 3 weeks, and the system was really solid. It never crashed again. Well, I wouldn't say never, but rarely, instead of crashing often. So don't be afraid to use the rather abrupt handling of terminating your program when you know that you have a bug. As long as you terminate with information about what the problem is.
Right. Well, it does depend on your situation. If this is something that's running on your server, if you're running a web service of some sort, then that's something that you can address and do some. When I worked at Microsoft, I worked in the Mac user user group, and or business unit. And one of the things that we looked at, it was a different model than today, where you look at apps and you send out updates and things like that. I mean, we were sending out boxes with disks in them, and we knew that people were going to use this software for years because that's just what we knew. And so we had this weird philosophy of, even in the face of these kinds of problems, to try to degrade as gently as possible. So we actually would specify and say, this is the contract for our function. No guarantees if you are outside the contract, but in fact, we would in fact throw an exception and at least try to die gracefully.
Yeah.
So it was this kind of contradiction in what I teach today, which what I teach today is, no, you're outside the contract. It's all undefined behavior. And in fact, we tried to basically jump back to the event loop. It's possible that we lost data, but we probably only lost the data you just entered and not data that you've been using. And so it was possible to survive from there. You could do a save or something like that.
Yeah. But I guess that goes back to this paper I mentioned with contracts at work, where you can specify that this contract is one that a violation is survivable, and this other contract is not.
Yeah. But when you start to get to that point, you begin to ask what a contract is, and then you get in this weird situation. So I've never really defended what we did at Microsoft. We just did it because it was, in the situation we were at, it seemed to make sense. But it's not really defensible in an intellectual way. Either you're outside the contract, in which case nothing is guaranteed, or you're inside the contract, in which case the functions have to handle it in some way, whatever's appropriate. Right? Is your guarantee, or is your contract wide or narrow, and figure out what it is, and then behave appropriately.
Yep. And again, C++ doesn't really give us the tools to make this easy, but other languages that have this at its core, like Erlang, for example, they're predicated on the idea that things are going to fail and things will be left in an undefined state. And so you have them isolated in processes that are very cheap to pull down and bring back up again. Mm-hmm. And then the integrity of the rest of the system is preserved. And these are just communicating processes. And to some extent, we can do that with C++, of course. We just had to do a lot of the infrastructure work ourselves. So for highly resilient server-based systems, that is an approach that's often used, and sort of getting into the territory of microservices, which have a bit of a bad name with some people, but that is one good property about them, is that they do have certain resilience to parts of the system going down without impacting the integrity of the rest of the system. So there are ways to mitigate that.
So are you going to be in Kona next week?
Nope, I'm not. I am, however, going to present this again at ACCU in April, and I have absolutely no idea what that presentation will be.
Because it depends on what happens next week in Kona.
Yes.
Is that what you're saying?
Yes. The most interesting outcome will, of course, be that there will be no contracts in the language after next week, and then I have absolutely no idea what I will do.
Well, I don't know what's going to happen, but I kind of can't imagine it's going to go away. There's an awful lot of people who invested a lot in it. There's so much to be gained, even with an imperfect implementation. And I think the last time we brought this up, contracts on this show, I went off on the fact that in the post condition, you can't refer to the value that's passed in. And that's the way they had defined it. And the reason it's obvious from an implementation point of view, if you pass something into the function, and that object is a move-only object, and it is in fact moved from, there's no way to know what the original value was. So you can't make a post condition that depends on the original value of something passed in. And so I understand why they said, well, you just can't do that. However, most post conditions are in fact going to want to be dependent on the value passed in. You're going to want to say something like, you're passing in an iterator. You're now going to want your post condition to say that at this location, this value will now appear, or something like that. Yep. And so you really, really want that feature, and to say, well, you can't use it. To me, that's just crazy. Even though I understand there might be situations where it literally can't be used, but that's going to be a really corner case. And you can make language that says that the compiler at compile time can recognize that that is not it's not achievable to make that check because you're trying to test a move only object. If it's not move only, it's expensive because you'd have to copy it, but at least you can do that. And if that's what the user has specified in their post condition, then that's what you would have to do.
Yes. Yeah, I would like to see such a change also, that the compiler can tell you that what you have now stated will not be checkable, therefore it is a compilation error.
Or the compiler could just tell you that it won't be checked and leave it alone because you're giving value. If I say my post condition depends on, this is my post condition, that it's some function of some value, some parameter value, and the compiler can say that's not checkable, but I leave it there because someone reading the code would realize this is what I'm saying is true of the post condition. At least that's information.
Then the compiler could error unless you make it an axiom. And that would seem reasonable.
Well, maybe that's the way to go. I guess I don't know enough about what's offered in the standard, but that's such a bizarre corner case. I mean, yes, it's theoretically possible that it can't be evaluated, but how often do we use move only types, and how often are we going to have post conditions that are going to be based on the move only types, and how often are those move only types going to actually be moved from in the object? If it's not moved from, then you can still compare to it.
Yeah. And especially not only that, but also referred to in the post condition.
Yeah. So it's a confluence of of corner cases on top of corner cases, and to give up this feature that's really going to be useful a lot of the time. It's a major benefit of post conditions, of being able to specify that post condition. I think that's something, but I would also say that's also something that we could change later. In other words, right now we might say you can't write a post condition based on this, but later on we could have that fight if the rest of contracts goes in. And so for 23 or something like that, we could have new language that says, well, yeah, I guess you can use the post condition with these limitations or something like that. We can, it's not like some of the things that are going into the standard, I might get all upset and say, no, you can't. If you put it in wrong, we'll live with that forever. But this is one where if you put this in this way, it could be fixed in the future, I think.
Yeah. I also think that there are problems here, but they are not unsurvivable problems. We can live with them and we can improve them. And I also think that there is a great value in having the language support, because that makes it possible for library developers to have contracts enforced in their libraries, which is something that today is not possible, because then you have to agree on which of many also library solution mechanisms for checking contracts should be used. Now, if this goes through, then we have one way of checking contracts, and that is the language supported way, and that is good.
Yeah, that's why we have standards.
Yeah, we're getting to the point where we're going to need to check our post conditions.
Oh,
that previous episode where we talked about contracts, by the way, was episode 32. I'll put a link in the show notes. We had a discussion with John Lakos.
But we have ODR use that, so now it's a undefined behavior to refer to it in the post condition.
All of this show is undefined behavior. Just again. I mentioned at the start that your video, Björn, from C++. Oh yeah.
Phil, let me say one thing about behavior. I've been called out at my interview style with Nico when he was on. Some people thought I was inappropriately behaved, and I apologize. I never want to offend everybody. I do want to make this show very free reign, and I think we should have fun, but I don't want to get overboard on that. So let me just say that, and then I didn't mean to interrupt you when you were talking to Björn there, but I wanted to say that quickly before we end.
Yeah, I don't think there's anything inappropriate or offensive. It's just you're interrupting people too much. So thanks for interrupting me to tell me that. So
anytime.
Beginning of the show, I did say that the video from C++ on C may well be part published or ready to be published by the end of the show. And I just had an email from a video guy saying that he's actually hit a bug in the exporting process. So I thought that's quite appropriate given the nature of the video. So that may take a little bit longer, but hopefully we'll be ready either later tonight or tomorrow as we record this, and certainly by the time the podcast comes out. So anything else you would like to cover before we close out, Björn?
No, I'm really looking forward to seeing what happens in Kona next week, and it will be interesting to see if I have something to talk about at ACCU in April.
Yeah, I hope so too. I think the problems that we have are either fixable or inherent, and we're better off with contracts than without them. Yes,
and what goes in the standard aside, I want to thank you for raising the profile of contracts in general. It's a very important tool for software engineers, and it's unappreciated.
Yes,
and underappreciated, and
yes.
I appreciate your raising that profile. Thank you.
Thank you.
Is it now time to wish everyone safe coding?
I think so. In fact, right. I think especially safe coding.
Especially safe coding.
Yes, stay within contract.
Yeah, exactly.
All right. Well, happy Valentine's Day, everyone, and we wish you all safe coding.
Safe coding.
Safe coding.